All right, this is the review for honors math test. I'm just going to go through a few questions and make sure you know how to do them. This top one is asking if xz is a tangent and explain why or why not. So if xz was a tangent, what is that going to say about yz and xz? How do they meet? And obviously if they were a tangent, they would meet at a right angle. Okay, if it's a right angle, what type of triangle do I have? I have a right triangle. What theorem can I use to try and prove it? Pythagorean theorem. So I'm going to set that up as a Pythagorean theorem. 8 squared plus 15 squared equals 18 squared. Square those out. 8 squared is 64. 15 squared is 225. Somebody help me with 18 squared. And I'll add these two together. So that gives me 289. 18 squared is?
324.
What is it?
324.
324. And so therefore they are not equal. Therefore is xz tangent. And you say, not tangent. Triangle xzy is not a right triangle. And that's going to be your answer there. If this would have been 17, by the way, the square root of 289 is 17, then that would have been a right triangle, and I would have said they are tangent, and it's because it is a right triangle. So that's all you got to do for that one. But the question's going to ask, is it a tangent or not? And you're going to do that by setting up a right triangle Pythagorean theorem. Okay, going to the next problem. This one's going to set up a quadrilateral with a circle inscribed in it, okay? And so we're going to try and figure this out using tangents. Realize that WD and WA are tangent to the same circle from the same point, so we know those are congruent. Same thing with XA and XB, same thing with YB and YC, same thing with ZC and ZD. So as I do this one, I actually want to write my values that I know for each of those small sides as I do it. So I look over here, I say, hey, XB is 8.8. So I know this one is 8.8. I also know AX is what? 8.8. They have to be the same. So if they go from the same point exterior, tangent to the same circle, they have to be congruent, okay? Same thing over here as I go to the next one, ZD. So I look, okay, here's ZD. If it's 14.4, then what does ZC have to be? 14.4. Okay, if YC is 10.2, then obviously BY has to be what? 10.2. That leaves us with this one that's kind of weird. It says that WX is 42. So the whole length here is 42. What do I have to do with the 8.8? You're going to subtract it, right? So we're going to do 42 subtract 8.8. And that gives us
33.2.
33.2. So what's WD? 33.2. Now all I do is add all those up, and that'll be the perimeter. I'm not going to do that, but you can do that if you need to. All right, going to the next one. Just make sure you know the difference between a chord, a radii, a diameter, a secant, and a tangent. You should have those in your notes. Make sure you do, and make sure you understand the difference between each of those. I just want to explain how you would write a secant compared to a chord. So if you ask for the secant should say x, y, with a line over it that extends, because the secant extends through the circle. If it asks for the chord, you would say xy with just a line segment, meaning it stops at x and stops at y. So the chord stops, and the line that extends is called a secant. Okay, next one. We're going to draw all common tangents to the two circles. To draw all the common tangents to the two circles, a lot of kids are going to get, oh, okay, I'm just going to go from this circle to this circle, common tangent. There's a point there, there's a point there, boom, good. I'm going to go from here to here. All right, good. And they'll think that that's all there is. But remember, we can also draw tangents that are what we call interior tangents going through between the two circles. So I need to draw those in also. And then down through here. Sorry, I didn't draw that one very good, but you get what I'm saying. So there should be 4 common tangents on that one, not just 2. A lot of kids are going to just draw the 2 common tangents. Make sure you draw all 4. These extend, sorry. Okay, but there's all your common tangents. So just remember that on the common tangents. All right, the next one we're going to do is central angles versus inscribed angles. What is the difference between the measure of the angle and the measure of the arc? So the central angle is equal to or congruent to the measure of the arc. Exactly the same. An inscribed angle is going to be half the measure of the arc, or twice the inscribed angle will equal the measure of the arc. Twice the inscribed angle is equal to the measure of the arc. You want to write these things in your notes to make sure you have them for the test, because you can use your notes on the test. But you can't use this review. You can't just watch it while you do the test. Tell your parents that. Okay, you're probably just going to cheat. Don't worry about it. All right, going on to the next one. We've got this little pie chart, okay? It deals with angle measures, though. So these are all angles. All right, every one of these is angle measures. So what I'm looking at when I'm looking at those angle measures is different than I'm looking at when I'm talking about the percentage. And that's what it's going to ask on the test. So it's going to say, what percentage prefer baklava as a dessert? And really, this is obviously a horrible pie chart because anybody who's tasted baklava knows it's delicious. Nonetheless, we're going to say that this is an uncultured person from Carbon County. So that's what we're going to do. So now we have to do baklava, and we have to do it as a percentage. A lot of kids are going to write 34 thinking that's the percent. It's not. You need to take 34 divided by all the way around a circle. What's all the way around a circle? 360 degrees. So I need to take 34 divided by 360.
10.588.
So we have 10.588. So we're going to round that to 10.6% of the people prefer baklava. Do not use the 34. That's what kids are going to miss that one. You're going to miss it because you're going too fast. Stilson, I'm talking to you. All right, slow down. Make sure you divide 34 by 360. All right, next one. It's going to give you this picture right here. And it's going to say, hey, X, Y is congruent to A, B. And then it's going to say something like this. LM equals 5X plus 2, and MN equals 3X plus 28. Solve for X. Okay? Now, you may say, all right, XY is congruent to AB, but what does that say about LM and LN? Well, if the chords are congruent, the distance from the center to the chord has to be the same. They are also congruent. So therefore, LM is congruent to MN also. Because the chords are congruent, their distance to center is congruent. So I'm just going to set up an equation where these two are equal to each other. 5x plus 2 equals 3x plus 28. I'm going to subtract 3x. That's 2x. I'm going to subtract 2. That's 26. I'm going to divide by 2. That's going to be 13. That's my value of x. That's all. Okay? This one over here is a little bit tricky. A lot of people are going to think that both arcs are congruent. You should be able to see that they're not. But you need to figure out which arc is congruent because you know it. So let's think about this circle here. We have a circle. We have an angle measure of 145 here. We have a measure of 85 here. We have this mark congruent with these two sides, and we have these two sides marked congruent. Well, because of that, if you think about a chord going through here, It won't be drawn in the picture, but you can think about these chords. Can we say that these chords are congruent? Can we say these triangles are congruent? Think about that for a minute. How could we show those triangles are congruent? Well, obviously we have vertical angles here, and so therefore we have side angle side. If side angle side is congruent, then these sides also must be congruent. Okay? Well, if these chords are congruent, the arcs they create must be congruent. So if this is 85, this has to be what? 85. It's really hard to teach when nobody answers my dumb questions. All right. So therefore we have 85 and 85 and 145. This is not the same, notice. This triangle, if I was to draw CD and I was to draw AB, sorry, I erased my B there. If I was to draw AB and DC, they would not be congruent because these side lengths and these side lengths are not congruent. So therefore, that's not going to work for these two triangles. So now I have to just say, all right, I want to find all of the arcs. Well, I found AD already. AD, arc AD, sorry, I should have put arcs on those. Arc AD is 85. But how will I go about finding arc AB? Well, again, I just have to remember all the way around the circle is 360. So I'm going to add 85 plus 85 plus 145.
45.
Add them up and then subtract it from 360 and you get 45. Somebody was ahead of me. All right. So AB, the arc is 45 degrees. Okay. Last one, or not last one, but next one. All right, here we have an inscribed angle. The other thing that's interesting about this one, and that a lot of kids won't pick up on, is the AC, because it has B marked as the center of the circle, AC is a diameter. So what is the measure of the arc AC? Well, if this is a diameter, the measure of the arc AC has to be 180 degrees also. So you want to take that into account as you do this. Now, this little angle in here is 31.5. What did we talk about with inscribed angles? This is not a central angle, it's an inscribed angle compared to the arc. What should I do with this angle? Double it. So I'm going to double that value. 31.5 doubled is 63 degrees. And like we just talked about, all the way from A to C has to be 180, right? So I'm going to do 180 minus 63, and that will give me the arc AD. 117 degrees. Okay? Moving on. Now we're going to talk about an exterior an exterior angle with arcs. Okay? An exterior angle with arcs, the key thing here that you have to think about is that if it's on the outside, I need to subtract. If it was on the inside, okay, where you had arc, say this was 43 or 49, let's say that, and this was like 98, you'd have to add these and divide by 2. So here we would add and divide by 2 to get this angle. Here, because it meets on the outside, notice these meet on the inside, you add on the inside, you subtract on the outside. So therefore, we're going to subtract these two arcs and set them equal to the angle. Okay, or sorry, set them equal to twice the angle. So I'm going to take 5x minus 17 minus 2x minus 1. Notice I have to distribute the negative through both of those. Okay, this should, oh wait, this equals, so half of this equals this angle. So therefore twice is what I have to remember to do that angle. So this is going to be 39 doubled, which is 78. Most kids, when they mess this up, are setting this up equal to 39 instead of 78. Don't forget to double the angle. Don't forget to double the angle. Okay, so now I just add these together and solve it. I'm going to go 5x minus 2x is 3x, negative 17. Don't forget to distribute the negative through there either. And then I get negative 18 equals 78. Add 18. That's going to be 78 and 18, 96. Is that right?
Mm-hmm.
Okay. Equals 3x, divide by 3, and x will be 32. Okay. So remember, if it meets on the inside, you add. If it meets on the outside, you subtract. That's how you do it. If it's on, so let me explain what it would look like if it was on. That would be like a tangent line here. Okay, and then it meets like that. Okay, therefore you would have the arc AB. Okay, if it meets right on it, then it's obviously half the measure of the arc. Okay, so again, you always have a 2 in there. You have to double the angle. You'd have to double this angle. You'd have to double that angle to equal the measure of the arc. This one you subtract the arcs. This one you add the arcs. This one you just take the same arc. Just take half of it to get the angle. All right, the last type that's on the test is right here. It's just going to be where you're trying to find the point that the circle and the line meet. So remember, you're going to have some sort of circle and some sort of line. It could meet at one point. Okay, if it was a tangent line, it could meet at 2 points. If it's on the circle, it could not meet at all. The line could be here and the circle could be there. If you end up with this, when you do it, you'll end up doing quadratic formula and you'll end up with a negative discriminant. The part under the root will be negative if it's going to be no solution. If it goes between, obviously you'll have 2 solutions. You can do that either by factoring, quadratic formula, completing the square. Those are the methods we've learned. If it meets on, you'll only have one answer. You'll use the square root method and it'll be equal to 0. So you'll end up with only one answer on that one. So this one, we don't know what it looks like for sure. We're just going to try and solve it. So the way we solve this, though, you can only solve by substitution. Do not try elimination. Don't try and square this side and square this side, square out. You're going to get completely confused. Don't use elimination. Use substitution. So substitution just says, hey, we're going to take this value of y, negative x minus 2, put it in for that y. Okay? Doing that gives me negative x minus 2 plus 3. That plus 3 is still there. And then I'm going to square that. So negative 2 plus 3 is negative 1. So I have negative x minus 1 squared. I'm just going to square everything out now. And then I'm going to solve it by setting it equal to 0. So I'm squaring out this first value, or this first binomial. I'm going to square that binomial out. Now there's a quicker way to do that I've already taught you, which is first term squared, first term times second term, times 2, last term squared. That's what I'm going to do it. So first term squared, x squared. First term times second term, that's negative 5x. Doubled is negative 10x. Last term squared, plus 25. Remember to do the first term times second term times 2 to get that middle term. Usually kids end up messing that up. They square the first term and they square the last term, but they forget the middle term. Don't forget the middle term. Same thing over here. As I square this value out, I'm going to take first term squared. That's going to be a plus because a negative times a negative is a positive. X squared. First term times second term, again, negative times a negative is going to be a positive. X times 2 is plus 2x. Last term squared is going to be a plus 1 equals 36. Now I'm going to combine my like terms. X squared and x squared gives me 2x squared. Negative 10x plus 2x gives me negative 8x. 25 and 1 gives me 26. Equals 36. Subtract 36 from both sides. That's going to give me 2x squared minus 8x minus 10 equals 0. The reason I subtract 36 from both sides is I notice I have a square. That tells me I've got to set it equal to 0. It's a quadratic. I'm either going to solve this by factoring or quadratic formula. You could do quadratic formula right now. I'm not going to do that. I'm going to divide everything by 2. So I'm dividing every single term by 2. That ends up being x squared minus 4x minus 5 equals 0. And then I say, all right, this one looks like it might be factorable, so I'm going to try and factor first because it's always easiest if you factor first. So I'm going to take, if not, you'd have to use quadratic formula. So here I say, all right, I've got a 5 here what multiplies to be 5 and subtracts to be 4. I think in my mind, what multiplies to be 5 subtracts to be 4. Well, there's only 2 of them. I mean, a first grader could figure that out. X and X, 5 and 1, that's going to subtract to be 4. So now it's a difference on that last term. So the signs are different. The bigger one gets the sign in the middle. So if this is a difference, these signs will be different. If this is a sum, these signs will be the same. Don't notice I didn't put my sign in until the very end. So it's a difference. Signs are different. Bigger one gets the sign in the middle. That's why the 5 has the negative. The other term gets the opposite sign because it's a difference. So they're different signs. Equals 0. Notice that negative 5 plus 1 would be negative 4. That's what you're kind of looking for. All right. Now I'm going to set these equal to 0 and solve. So x will equal 5. Again, x minus 5 equals 0. Add 5. Or x equals negative 1. Okay? So it's one of those two values, either 5 or negative 1. And actually, it's both. Do not finish thinking you're done at this point. You need to find the 2 points. So remember, we had a circle. These are two x values of 2 different points. Okay, one of the x values is over here at 5 and some y value. And one of these x values is at negative 1 and some y value. So now I got to find the y values. Easiest way to do this, though, is just sub it into the linear equation. Don't sub it into the quadratic. So now I'm going to put in a 5 right here. So one of my points is 5 for the x value. Putting that in there gives me negative 5 minus 2, negative 7. That's one of these points. And then my other point is going to be when I put in negative 1 right here. Negative times negative is a positive 1. 1 minus 2 is negative 1. These are the 2 points on this circle that line is crossing. That's your review. Have fun taking the test.